Alrighty, folks, today we're going to look at the special ratios for the special triangle. So this concept becomes huge in not only 30-1, but even the beginnings of calculus as well. This is probably the most important section in our trig unit. So for angles of 30, 45, and 60, you can determine exact values of trig ratios. So the reason why this is so important, when you go to post-secondary, university, college, McEwen, U of A, wherever it is, and you study a math course, you won't be given a calculator. You essentially just get a pencil and an eraser and say good luck. So it's going to be helpful to know how to figure these out without using your calculator to do inverse functions and to use those trig ratios. So we'll keep it here for now, but this is going to have huge implications for your future study in math. Those exact values, numbers that aren't approximations, integers, fractions, radicals, all examples of exact values. Not exact value would be a rounded decimal. Okay, we've seen some exact values in the past few lessons, and we'll continue this throughout this one as well. So remember some of the things we talked about before. You can use the quadrants and the cast rule. So this tells you cosine is positive, all of them are positive, sine or tangent is positive depending on where you are. This helps us identify the signs of those trig ratios. The trig ratio for principal angles can be written using reference angles and the signs from the quadrants. So we can reflect that terminal arm into whatever quadrant we need and have our sign accordingly, depending on which quadrant we've reflected in. By using right triangles with side lengths of x, y, and r, that's our hypotenuse, and the angle being theta, the reference angle, we can write exact values for each trig ratio. So that's what we've been doing for the past two lessons. Okay, this is what we call one of those special triangles. We'll talk about why it's special in a minute, but use the diagram to determine the exact primary trig ratios of 60 degrees. So I can see I've got my origin point, I've got a terminal arm, I've got another arm coming off of it. So this is an isosceles triangle here. We're only going to really look at half of it. So my terminal arm length 2, I've got an angle of 60. That's my reference angle coming off that x-axis. And I've got an x-coordinate of 1. So this point A would have coordinates of 1 and whatever that y-coordinate is. At the moment, we don't know it. So let's go ahead and find that y-coordinate right now. Now we could do that by using our formula we learned before. So square root of my r squared minus my x squared this time. So my r squared is going to be 4. Since it's 2, I'm squaring it to place it in there. So that's 4 minus 1 underneath. So my y is actually the square root of 3. Leave it as that, no decimal or anything, and we can place that in. So now we know what our y-coordinate is. Okay, so let's go talk about those trig ratios. Let me make sure I get them correct. So I'll keep my notes here. So let's do sine first. So let's do the sine of 60 degrees. So sine of 60 degrees, I've got my 60, which means I'm looking for the opposite divided by the hypotenuse. So I can take my root 3, divide it by 2. So this is going to be the exact value of the sine of 60 degrees. We can do the same thing for cosine of 60. So that's going to mean we're going to take our x-coordinate of 1, divide it by our hypotenuse. Cosine of 60 is actually 1/2 or 0.5. Now hopefully this works. Yeah, so you can see right there on your calculator, cosine 60 is 0.5, and we know that now. Let's do tangent as well. So tangent of 60 is going to be my y-coordinate divided by my x-coordinate. So root 3 over 1, that'll just give us root 3. So here's some exact values now. They're not decimals, they're fractions, and they've got roots in them, so I'm not going to evaluate them and get a decimal. We're going to leave them as they are. That'll give us those exact values of those angles. Okay, we're going to use the exact same diagram, so I'll redraw it underneath, to determine the exact primary trig ratios of 30 degrees. So now things are going to change. Now, let me see if this will actually work. I might be able to just straight up copy this image. Oh, perfect. So I don't have to redraw it. You might. Oh, it doesn't work. That's okay. Let's redraw it. So give yourself an axis. And my terminal R, I'll make it a bit larger so it's easier to see. And again, we'll just use the half of the picture. We only really need to. So here's my 60 degrees in the corner like before. There's my point A up above. 2 was our hypotenuse or our terminal arm length. And 1 was underneath. Now, if I'm going to try to do this for the angle of 30 degrees, if you look inside that triangle, I've got an angle of 60, an angle of 90. In total, that's 150 degrees. So I know that this missing angle has to be 30. So we're essentially using the same picture, just a different reference angle to do this. So here we'll use 30 degrees to do this. Now, if this is the same triangle, my y-coordinate should still be √3. Okay, so we're going to write the ratios according to the 30-degree angle instead of the 60-degree angle. And we'll start with sine again. So the sine of 30 degrees this time is going to be opposite over hypotenuse, so 1/2. Cosine of 30 degrees adjacent, which is √3 now, over hypotenuse, so √3/2. And then tangent 30, opposite over adjacent, so 1 divided by √3. Okay, so I've got all my ratios. They are all in exact value form. No rounding, no decimals needed. And we can look at something that just happened. So compare the ones in the black to purple. So what do you notice? So the sine of 60 was √3/2. But if I look down below, that's also the same thing as the cosine of 30. They have the exact same value. Cosine of 60 is 1/2. Sine of 30, also 1/2. They have the same value also. But tangent is where things change. So tan 60 is √3. Tan 30 is the reciprocal of √3. So that one got flipped over. So let's write those out down below. So we can say that the sine of 60 is equal to cos 30, or cos 60 is equal to sine 30. And you could also say that tangent 30 degrees is equal to 1/tan 60, the reciprocal. So these relationships are going to help in the future, but now we can start building off of them. So I know I have some equivalencies here now between these two angles. Okay, this idea you can use for a 45-degree angle as well. So we only talked about 30 and 60, but 45 is the other special one. Now for that triangle, we're going to make the hypotenuse 2, and since both sides are equal, the legs have to be √2. So if you were going to make each side x, use the Pythagorean theorem to solve for those legs, they would both end up being √2. Now, I know for this triangle, we used a terminal arm length or a hypotenuse of 2. Down below, we're going to use a hypotenuse of 1. So all we're really going to do is cut each dimension in half. Okay, so I'll divide 2/2. That'll give me my hypotenuse length of 1. 1/2 for my one leg, √3/2 for the other one. So this is how we're making these triangles now. So underneath, we've got 3. Really, it's only 2 different triangles. One of them we can just kind of turn. So we'll start with the first one. The labels are most important. So I've got my right angle in there. Hypotenuse of 1, like I said before. So before it was 2, this time is 1. So we're going to cut those dimensions in half. My angles are going to be 60 degrees and 30 degrees. Okay, so now we're going to see what happens to those legs. So one of them was 1, remember. So now we're going to make it 1/2. The other one was √3. That was our y-coordinate or our height. I've just kind of switched them. So now this one, instead of being just √3, it's going to be √3/2. We cut every dimension in half. Okay, so here was 2, 1, √3. Here's 2/2, 1/2, √3/2. Okay, so I just cut them all in half. Now let's go talk about the sine of 30 degrees. I know I'm going to need my coordinate. So this time this is y. This one on the bottom is x. And this is my hypotenuse. Okay, so opposite over hypotenuse. Sine of 30 is 1/2. I'm fairly confident that's what we said before. Sine of 30, 1/2. All we did was really rotate this triangle, so nothing really changed. Okay, sine of 30 is going to be y/1. So sine of 30 is going to be 1/2 divided by 1. So sine of 30 is 1/2. If we do the sine of 60, start up here, my opposite would then become whatever I just called x. So keep in mind, I labeled them according to the 30. So sine of 60 will be √3/2 divided by 1. Tangent is going to be the opposite divided by the adjacent. So this triangle actually gives you all of those exact values. Now, it might be hard to remember where things are going to go. The thing that I found helpful when I was learning this, so this is the same triangle I used when I was in grade 12, 10, 11 years ago. If you start labeling it and you remember that 30 is 1/2 of 60, you have the entire picture pretty much. So if you remember that 30 is 1/2 of 60, all you really have to remember is root 3 over 2. Okay, the rest of it falls into place. So 30 is 1/2 of 60. Place your root 3 over 2 where you didn't yet, and then 1 is always going to be your hypotenuse. Okay, we can build the same triangle over here from nothing. So let's use blue this time. So let's say 30 is 1/2 of 60. All I have to remember, root 3 over 2. My hypotenuse, always 1. Okay, so this will now tell you everything you need to know. It's the same triangle as before. All I've really done is, again, rotated it. So if I now try to use this for something, if I am looking for the exact value of, let's say, tangent, actually that's not too tangent. Let's say I'm looking for the exact value of sine of 60. Okay, I locate my 60, opposite to it, root 3 over 2, divide it by 1. Great, now I know that the sine of 60 is root 3 over 2. Done. Okay, all I need to remember is 30 is 1/2 of 60. And the other two things fall into place. I'm always going to have a root 3 over 2. My hypotenuse is always going to be 1, no matter how this triangle's rotated. Okay, but now let's do the last one as our isosceles. Let's do this one for 45, because we haven't done that one yet. So 45 degrees for both of these this time. Again, hypotenuse is 1. Now, if I do that, that means that this leg and this leg have to be the same length. Okay, so they're identical. Now, the only way that will work out is if those two legs are root 2 over 2. Okay, the other way you could try this, let's assume you didn't know what they are, and you called them both x. Okay, so we could say that x squared plus x squared is equal to 1 squared, because our hypotenuse, oh, actually, that's supposed to be a 2. Let's make that a 2. Yeah, hypotenuse is going to be 2 here. Okay, so let's just go double check this to make sure I've got it all right. So I have 2x squareds, and that's equal to 4. So x squared is equal to 2. That means that x is going to be the square root of 2. Now, yeah, I know what I did. Okay, so if it's 2, then my x's are going to be square root of 2, but we're going to change this hypotenuse so it actually says 1. Okay, we're going to keep it as a hypotenuse of 1 to keep it consistent through all 3 triangles. So now if you divide every dimension, I think I'll change the color, divide every dimension by 2. See, it happens to us too. We sometimes get confused. So now my hypotenuse is 1. Okay, so if my hypotenuse is 1 now, my legs are going to be root 2 over 2 for both. Okay, so try to remember that your hypotenuse will always be 1. Okay, I use 2 to get the legs, and then I can convert them into 1s. Essentially what I did above. So I used a hypotenuse of 2 to get the legs, converted the hypotenuse so it was at a 1. Okay, same idea. So remember that your hypotenuse will always be 1. Your legs will change. Okay, we can put all the results into a chart as well if that helps you visualize it. So if I've got an angle of 30, sine of 30 is going to be essentially just my y-coordinate from our triangles above. Okay, so 30 is always 1/2. If it's the cosine of 30 degrees, I'm always looking at my x-coordinate. So here's cosine in purple, x-coordinate root 3 over 2. Blue one, x-coordinate root 3 over 2. My adjacent, essentially. Okay, so root 3 over 2. Tangent is going to be the one where you have to take your opposite and divide it by your adjacent. So if it's the tangent of 30, I'm going to take 1/2, divide it by root 3 over 2, which will look like 1/2 being divided by root 3 over 2, which is the same thing as a half multiplied by 2 over root 3, which is 1 over root 3, like we said it was originally. Okay, so you can go through that process as well. I'm just going to fill in the rest of this chart for you. 45s are nice because it's always the same. Root 2 over 2, cosine, root 2 over 2. If you take tangent, then you're going to divide your x-coordinate, which is cosine, by your y-coordinate, or sorry, your y-coordinate, which is sine, divide it by your x-coordinate, which is cosine. and that will give you tangent. So if it's root 2 over 2, that's 1. You're dividing the same thing. Okay, y divided by x. Sine of 60 then is going to be whatever cos 30 was. That was the relationship we came up with before. So that'll be root 3 over 2. This one will be 1/2. When you divide those two, you get root 3. Okay, so I'll leave you to check that one. Underneath, we've got a couple examples how we can find them now. So determine the exact value length, no decimals. The calculator really isn't going to help here. Okay, find the quadrant to identify the sine, get the reference angle to use special triangles, write the ratio. So a picture is going to help always. Give yourself a little grid. 135. So we can't be in quadrant 1 because that one goes up to 90. I can't be in quadrant 3 because that one's bigger than 180. So I know I'm in quadrant 2 somewhere. So here's my angle. Roughly, I know it's in this quadrant. Now, this principal angle is going to be 135 degrees, which means this reference angle that we're going to use needs to be 45 degrees. Okay, the reason why I know that, those two have to add up to 180 to complete my semicircle. So that means that the sine of 135 degrees is equal to the sine of 45 degrees. Okay, these two ratios take me to the same terminal arm. Direction is just different. Okay, so if I start here, I need to do sine of 135 to get to that terminal arm. If I start down below on my x-axis and go up 45 degrees using that reference angle, sine 45 will take me to the same place. If you're not sure, you can always check it in your calculator. So sine of 135 equals, and then sine 45 equals. They need to have the same value, which they do. So those two take me to the same point, which I need. So now I just need the value of that as an exact number. Sine of 45, that's 45 degrees. I know that's a special angle that we need to know. So that means my 45 degree triangle has root 2 over 2 for x, root 2 over 2 for y, 1 as the hypotenuse. And you can see that just up above. So the sine of that, I need the y, or just the opposite side. So that means the sine of 45 degrees is going to be root 2 over 2. And I'm basically done. I was asked for the sine of 135. Since I know sine 45 is equal to that, now I can say, so therefore, sine of 135 degrees is equal to root 2 over 2. Okay, as long as I remember those special triangles, my work's pretty much done. Let's try B. Tangent 135. So same picture, angles in the same place. And here's 135 again. That means my reference angle that I need to use this time is still 45 degrees. So we can say that tan 135 degrees equals tan 45 degrees for the same reasoning as before. Tangent 45 degrees. I need to take root 2 over 2 and divide it by root 2 over 2. Tan of 45 is going to give me 1. So tan of 45 degrees equals 1. Therefore, tan of 135 degrees also equals 1. Check it out. Oh, negative. What did I forget? Oh, quadrant. C, A, S, T. The quadrant that this terminal arm is in actually means that tangent needs to be negative. So even though I got the value correct, I got the sign wrong. So this is where your calculator might come in handy. So even though the tangent of 45 degrees is 1, the placement of this terminal arm needs me to double check the sign. So always double check that. I didn't really run into that issue for this one since I was looking for sine. Sine is positive in this quadrant anyways, so I didn't even really need that there. For tangent, however, tangent is negative in this quadrant. Okay, since that terminal arm is there, I should be double checking every time. Okay, so tan 135 actually needs to be negative 1. Okay, so it's a good thing we check that on our calculator just to make sure we got the right sign. Value will always be the same. The sign might be different. Okay, so that tangent 45, it's kind of like it's checking it in that first quadrant. Okay, because that's where my 45 really should be as a principal angle. But since it's 135, it's in a different quadrant, so I should be checking that sign also. Okay, let's try D, tangent of 300. So let's give ourselves another grid. 180 takes me halfway around. 270 takes me to quadrant 3, the end of it. So I know I'm in quadrant 4 somewhere. Okay, so all the way around to get there, that's 300, which means that the reference angle we're using, 60 degrees. Okay, so now I know that tangent 300 is equal to tangent 60. So I need to go locate tangent 60. 60 is one of our special angles. So let's go check up above so we don't have to build it all from nothing. Actually, maybe we should. Let's draw our triangle. And hopefully we do all of this correct. Okay, so here's my right triangle. Here's my right angle. Let's start with 30. So 30 is 1/2 of 60 root 3 over 2. And there's my 1. So I know I'm looking for 60. 60 is here. Opposite divided by adjacent. So I need to do root 3 over 2 divided by 1/2. That's the same thing as multiplying by 2. So root 3 over 2 times 2 will just leave me with root 3. So now I know that tangent 60 is equal to root 3. So I know the value of tangent 300 is root 3, but I need to make sure that my sign is correct. So CAST, I know that tangent should be negative here. So by doing all of that, my logic tells me that tangent 300 should actually be equal to negative root 3. Okay, and we can check this also. So let's we'll clear that out. Root 3 in so we see the decimal. So tan 60. Okay, same thing, because that really, like my calculator's thinking, it's up in that first quadrant. Everything's positive. So let's check tan 300. Tan 300. Bingo, negative, same value. Okay, so now I know that I did everything correctly, but representing it as that exact value, if you didn't know this, your calculator has the ability to place things in fractions for you if possible. So if it's rational, it will. If it's irrational, it won't. So root signs are no-go. Those are always irrational for the most part, trying to put them into fractions, unless it's a perfect square or something. So here, I know I got the values right, but coming up with the actual exact value came from us using this relationship with the triangle. So again, 30, opposite was 1/2. 30 is 1/2 of 60. Root 3 over 2 goes in. Hypotenuse, always 1. You can always build this triangle if you remember that. Okay, so there's how we would do this to find out what those exact values are. We can use that same idea to kind of do the special ones. What happens if it's 90, 180, 270? What about the other angles? So let's check this out. So if we do a point, let's consider a terminal arm of length 1. That's important because that's essentially my hypotenuse. Rotate to the angles of 0, 90, 180, all those ones right on the axes. Okay, so here's my first point essentially. Let's start here. What happens if it's 0 degrees? The point hasn't moved. So that point has coordinates of 1, 0, because that's the length of my terminal arm right there. 1, that's my x coordinate. If we go to write out those ratios, let's do the sine of 0 degrees. Okay, so here's essentially my triangle. Okay. If it's 0 degrees, I don't really have an opposite side to go to. There isn't 1 there. So that means it'll be 0 over 1. Okay, that's the length of my terminal arm. There's no opposite side, so this is going to be 0. What about the cosine of 0 degrees? Well, I need my x coordinate, which is 1, divided by the length of my terminal arm, which is also 1. They're the same. So 1 over 1 is 1. Tangent of 0 is going to be my y coordinate from my point, that's 0. My terminal arm, actually my x length, sorry, y over x for tangent. So 0 over 1, that's 0. So now I've got some information about those. Let's rotate this. Okay, so let's rotate that up to 90 degrees. My point changes. It becomes 0 for my x coordinate, 1 for my y coordinate. Same idea. Let's use the values of those 2 points to come up with our relationship. So again, remember that sine is going to be y over your hypotenuse. So 1 over 1, sine of 90 is 1. Cosine of 90, x over your hypotenuse, cosine of 90 is 0. Tangent 90, that's going to be y over x. So 1 over 0, that's undefined. Check it out on your calculator. Tangent 90, error. Doesn't work. Let's do the next one. Rotate that again. New point, -1, 0. Okay. This, now we're at 180 degrees. So the sine of 180 degrees means I take my y-coordinate, divide by my hypotenuse. Sine of 180 is 0. Cosine of 180 is going to be x over hypotenuse, so -1. Tangent 180 degrees, that should be 0, because I'm going to do my y-coordinate divided by my x-coordinate. 0 divided by -1. And lastly, 0, -1. It's the last situation. So sine of 270 degrees is going to be equal to -1, because I'm going to do -1 divided by my hypotenuse length of 1, so -1 over 1, -1. Cosine 270, x over hypotenuse, that'll be 0. Tangent, I think you can guess what's going to happen already. That one's undefined. Okay, so the blue ones and the purple ones, very similarly related, and the reds and the greens also very similarly related. It depends on the location of those points. So if I'm at 0 or 180 in that horizontal line, that x-axis, my sine will always be 0, because sine is really just the y-coordinate. If I don't have a y-coordinate, it's 0. My cosine will be my x-coordinate always. And so if I'm in the x-axis, right along it, right along any of those points, cosine of 0 is 1, because my length is 1. Now, if that point was 10 at 0, and my length was 10, that would be 10 instead. So this will change depending on where that point is. Tangent will always be 0. And things change if you look at your y-axis. So that's where my sine coordinates or my y-coordinates come into play. My x-coordinates here are non-existent. They're 0. Tangent is undefined because I can't divide by 0. Okay, and again, you could put all that information into a chart, essentially what we just did. So I'm just going to rifle through them, fill them in here, because the information is no different. It's just in a chart format instead, for anybody that likes those. 0, 1, find, and then 0, 1, 0. Okay, so there's all that information. These ones are going to be really fast if we can kind of remember that idea. So cosine of 90. Okay, here's my grid, 90 degrees right up above. Okay, if it's cosine, I really just care about my x-coordinate, but there is no x-coordinate. If I'm right on the axis, x is 0. So that means that cosine of 90 is 0 divided by my hypotenuse length. So cos of 90 is equal to 0. Nothing to do, really. Let's do sine of 270. So here's another grid. 270 degrees is down below. Now, I don't have an x-coordinate again, but I do have a y-coordinate. So if we're going to do the sine of 270, we can pretty much assume where that point's anywhere. It's got to be down here. So if I assume that point's 1, let's just make it equal to -1. Now let's rewrite this. So sine 270, -1. And you can see that right here. Sine 270, -1. We're just picking a point that has a length of 1. Okay. Tangent 180, do the same thing. Place your point on there. Okay, we're using 1 just because it's the easiest. We built those special triangles using that hypotenuse of 1. 1 is going to make this a lot nicer. So let's do that once more. Tangent 180 all the way over here. Now, if that length is 1, you could then say tangent 180 is your y over your x. But I don't have a y-coordinate since I'm not off that axis. So my y-coordinate is actually 0. X is 1. That means tangent 180 is equal to 0. And you can see that in the chart, tangent 180, 0. Okay, let's take a look at solving some trig equations, and then all of our exact value stuff is pretty much taken care of. Solve the following if this is our domain. So our angle needs to be bigger than 0 or equal to 0, or less than 360 or equal to it. So we're not going to have any angles like 540, 720, nothing bigger than 360, and no negatives either. So we need to figure out how to solve this. We need to go find our angle now. Go backwards. before we were given the angle. So let's draw ourselves a little grid. Now, like before when we were solving trig ratios, the sign's important to tell us which quadrant we're in. So sine is positive here. So here's my C-A-S-T. Sine is negative in quadrants 3 and 4. So I know it can't be there, but it could be in 1 or 2. So I have to account for both. So my angle could be in here, or it could be the larger angle to take me into quadrant 2. But both reference angles are equal. So I can find a reference angle first, then I can find 2 principal angles. Let me draw those in red. So one principal angle in red, the other principal angle in pink. Okay, so those are what I'm really looking for. Okay, maybe I shouldn't use theta for those reference angles. I'm going to change that. Let's change those to x. And my thetas will label theta and theta in pink. Because I could have two angles. So x is going to be my reference angles. The thetas are going to be my actual things I got to find. So sine of theta is equal to 1/2. Now, we also know from our special triangles, and if you've forgotten, let's just build one. That's not a triangle. That's definitely not a triangle. What is going on? Okay, that was a lot of work. Let's do 30 is, I'm going to move it over, sorry. 30, 1/2, 60. This is √3/2. There's my 1. So if I need the sine of 1/2, the angle that will do that for me, I need to have them opposite. Because if I try to use 60, that would be opposite divided by 1. Sine of 60 is √3/2. I need to use 30 because the opposite's 1/2. So sine of 30 is 1/2. So 1/2. Okay. So now I know what my angle is. I know that the angle I can use here is 30. Now that means my reference angle for x is 30. Okay, that means x, my reference angle is equal to 30. That also means that one of my angles that I could have is 30. Since the x and the theta are the same, that takes care of my quadrant 1 scenario. But I've got to get my quadrant 2 scenario. And I can do that by basically taking 180, the whole thing, subtracting out the piece that's the reference angle. That will leave me with my second principal angle. So if I do that, that would basically be for my second one. I could do 180 degrees minus the 30, and that would tell me that theta could also be 150 degrees. There's 2 choices here. So we can double check it. So sine 30 should give me 0.5, and sine of 150 should also give me 0.5. There are 2 answers here that do exactly what I need them to. Okay, so we've solved this. Both fall within our domain of 0 to 360. There's my 2 angles. One is 30, one is 150. Okay, let's do b this time. So I've got a square root of 2 in there. So as soon as you see a √2, you should be thinking 45s. Sine's positive again, so it could be quadrant 1, could be quadrant 2. My reference angles are labeled as x. My 2 thetas are those different colors that you see me writing. So one's red, one's green. There's my 2 thetas. So this is my ratio that I got to work with. So let's draw our triangle out first. So there's 1. This is √2/2, √2/2. Both angles are 45s. So it doesn't really matter which one I pick. So if I take a look at this, I only really know 2 sides of my triangle here. Okay. My y-coordinate and my hypotenuse. So what you could do is label one of them. So let's take out one of those angles from that grid and draw another picture. So this was x, what we labeled it as. So I'm just kind of pulling this angle out so there's less to look at. So if I use my ratio, this tells me that this is my y coordinate, this tells me this is r, so this is root 2, y is 1, so here's 1. We can go find our x coordinate now. So this is going to mean that x is equal to the square root of r squared minus y squared. Now if r squared is root 2, that means if I square it, I get 2. If I square y, I get 1. So 2 minus 1. So x is actually equal to 1 as well. And it should be, this is an isosceles triangle because we have 45s. Okay, so x is now 1. So now I know that if I did the sine of x, opposite hypotenuse, 1 over root 2. Okay, so now I can be certain that this is 45 since those two side lengths are both 1. They're isosceles. If this is a right angle triangle, the other base angles have to be the same, okay, to give me those equal side lengths. So now by doing that, by double checking that side length, I now know for sure that x is 45 degrees, which also means that theta is 45 degrees, my red theta anyways. So now I've got to go get my green theta. And I can do it the same way, take my whole semicircle for the top part of the Cartesian plane, which is 180 degrees, subtract out my reference angle of x on the quadrant 2 side. That'll get me to my green one. So 180 degrees minus 45 degrees. My second possible angle for theta is 135 when you subtract. Okay, and again, you can double check. So 1 over root 2. Let's get the decimal equivalent first. So this is what I need. So sine 45, that checks out. And sine of 135, that checks out also. So everything looks good. There's my 2 answers. Okay, if you want to try these 2 on your own right now, I would pause the video. I'm going to keep doing the solution. So in about 2 seconds, I'm going to start talking. So if you need to pause it now, and you can try them out, come back to the video once you've got them, see how you did. Okay, so let's do C. Let's do grid first. Cosine needs to be negative. So C, A, S, T. Cosine is positive here, so I know it's got to be in quadrants 2, 3. So these 2 are out. So there's theta underneath. There's theta again. 2 reference angles. Again, I keep getting into that habit. I'm going to label them x. X, x. Okay, my thetas are actually going to be the whole things. All the way. Okay, so we got to find the reference angles first. So if it's negative root 3 over 2, we can say that cosine of 30 is root 3 over 2. So we can use that as our reference angle. It's negative because of the quadrant it's in. So cos 30 equals root 3 over 2. Okay, it's negative because of the quadrant, not the angle. So that's root 3 over 2. So my angle is going to be 30. Now my actual angles for theta, the principal angles, that means theta could be 180 degrees minus 30 degrees, which would give me 150 degrees. And that should be the red one. Okay, my pink one then, I take my full 180 because I've basically gone halfway around, and I add 30 to get to the other terminal arm. So let's add 30 degrees. That'll take me to 210. Okay, so I still have 2 possibilities. Both still fall within our domain. So let's check them. Cosine of 150 gives me my negative, and I'm sure that's root 3 over 2. Let's just double check. Yep. And then cosine of 210, still negative, gives me the same value. So cos 30 gives me the positive one. So I know that's the value the quadrant is going to tell me the sign. So the value is important, yes, but the quadrant that it's in gives me the actual sign. So here's my two angles. One is 150, one is 210. Last one then for tangent. Tangent of theta equals to 1. That means I took a y coordinate and divided it by an x coordinate. Now, if y and x are the same, that only happens in one of those special triangles. This is going to be 45s. Okay, they have to be. So theta, instantly, you know, is going to be 45 degrees. But there's two choices. Since the sign of tangent is positive, it could be up in quadrant 1, because that's where all ratios are positive. It could be down in quadrant 3, because again, that's where tangent's positive. So one of them is the same as my reference angle, which my reference angle of x is 45. So in red, here's my first one. Okay, they're the same, so that's theta. The other theta happens if I start in the same position up on my x-axis, travel all the way around to get to my second terminal arm, which means I'm going a full 180 degrees and then 45 more. So my other theta is 180 degrees plus 45 degrees. So that second theta is 225. Okay, let's check. Tan 225, 1. Tan 45, 1. Okay, so we know we did it right. You can even check them on your calculator. You just can't use it to get those exact values. That you have to know. Okay, so that takes care of all of our stuff with exact value special triangles. Again, please make sure you're asking any questions if you have them. I know trig the one that kind of gets a little confusing, especially when you've got those two possibilities for theta. So please keep checking in with your teachers. We are here to help. And I guess there's two things left we have to do for trig, sine law and cos law. So look forward to those popping up in the next couple weeks. See you then.